NVIDIA's most tiny supercomputer, not just affordable and cheap. It's smaller than your lunchbox, but it holds the power of an entire data center. It doesn't make noise, it doesn't take up space, but it could change everything. Today, we're diving into one of the most underestimated breakthroughs in modern computing, a tiny supercomputer built by NVIDIA that might just reshape the future of AI, robotics, and edge computing. It's called the Jetson. It fits in your hand, costs less than a new smartphone, and yet it's capable of powering autonomous machines, AI-driven surveillance, robotic arms, smart drones, and even self-driving vehicles. Most people think of supercomputers as giant server rooms filled with blinking lights and million-dollar hardware. But NVIDIA flipped the script and brought all that power down to a device you could literally strap to a robot. Jetson isn't just small, it's a revolution in scale, access, and design. In this episode, we're lifting the hood on NVIDIA Jetson, from how it works to what makes it so special, and why this low-cost AI platform could democratize high-performance computing like never before. Let's break it down. Chapter 1. Meet Jetson Nano, the palm-sized powerhouse. Training an AI no longer requires server farms. NVIDIA miniaturized the supercomputer to fit into a pocket with Jetson Nano, delivering supercomputing capabilities at the unbelievable price of $129. Jetson Nano is the low-end AI computer provided by NVIDIA, a board that measures 70 by 45 millimeters in size and is targeted at machine learning, computer vision, and edge computing. It is powered by a quad-core ARM Cortex, a 57 CPU, and 128-core Maxwell GPU. Translation? It is small, yet mighty. When it came out, it disrupted the world of technology. Using only $129 or less with bulk or education kits, students will be able to construct facial recognition cameras, AI robots, or object tracking drones. They can do it without cloud computing or huge infrastructure. The special feature of Jetson Nano is the accessibility. It runs on Ubuntu-based Linux with full support of CUDA and TensorRT, and supports frameworks such as PyTorch and TensorFlow. This is not a thinly veiled gimmick. It is a legitimate AI development platform. It began to be used by smart doorbells, home security systems, and even theoretical greenhouse monitoring by developers all over the world, as well as the fact that it only consumes power of 5 to 10 watts, so you can power it with a power bank. The long and the short of it, Jetson Nano not only made edge AI possible, but practical as well. Chapter 2. Jetson Xavier NX, tiny but twice as brutal. Jetson Nano was awesome. Then there was Jetson Xavier NX, and NVIDIA was no longer kidding. It is 10x faster, just as small as, and capable of serious AI at the edge. Once NVIDIA phased out Jetson Xavier NX, the point was obvious to everyone: the future of AI is no more on the cloud, it is on the edge. Packing in a 384-core NVIDIA Volta GPU, 48 TC Tensor cores, 6-core Carmel-based ARM processor with 21 TOPS, trillion operations per second. This implies that it could perform complex neural networks, several high-resolution video streams, and real-time analytics all at the same time. And here is a kicker: it still fits in your palm. At a price of about $399, it is a small supercomputer that can be used in everyday life. Smart retail checkout systems, factory automation, and delivery robots, and even medical devices that can process data in real time. There is no need to sync to the cloud. It calculates everything locally and with latency of the order of nanoseconds. Companies are already using the Xavier NX in agriculture to detect crops, in retail, cashierless retail, and even drone startup companies to have real-time obstacle avoidance. It has a power consumption of less than 15 watts, is sustainable, scalable, and embarrassingly powerful. Chapter 3. Why tiny AI is the big future. In this world intoxicated with cloud computing, NVIDIA saw something that others did not. The next big revolution was not in the cloud, but at the edge. As everyone in the business world obsessed over the growth of server farms and the cloud, NVIDIA understood that AI would have to be even faster, inexpensive, and secure. This is where Jetson platform would come in. It is much more significant than the majority of people think. Cloud-based AI is very capable. However, it is cost-prohibitive, slow, and full of privacy issues. Consider the example of an autonomous vehicle that requires a system that can identify a pedestrian. The car cannot wait until a signal is sent to Amazon or Google servers and then get an answer back. That lag, however small it may be in milliseconds, can be a safety or disaster. Jetson modifies everything. Locating AI at the physical edge of the network, near where data is generated, it slashes latency and data security, enhances privacy and price cut. It is not expensive where you need to be online all the time. On the box, you get on-demand AI decisions. That is why Edge AI is gaining its popularity as a foundation of smart cities, medical devices, military systems, home appliances, and industrial robots. At its head is not a $10,000 server, however, but a $129 NVIDIA Jetson kit, a small, low-cost, low-power, massively powerful WT. Chapter 4. Robots Love Jetson. Here's proof. Whether it is a pizza delivery robot or self-piloting drone, NVIDIA Jetson boards are carrying the power of tomorrow. Here is how little AI is driving large automation. And not only tinkerers, Jetson is putting bots to scale, such as Agility Robotics, their bipedal robots delivering packages with Edge AI, delivers them anywhere on unpredictable terrain in real time. Or Clever Pet, who developed an interactive smart toy dog powered by Jetson Nano. Jetson is used by major universities in research, robotics research, and like Stanford, even Harvard and MIT. Why? Since it is also powerful enough to perform SLAM, simultaneous localization and mapping, computer vision, and reinforcement learning even on-device. Jetson has crept in as the de facto brains of DIY robotics kits. The well-known open-source robot called JetBot operates on Nano, following face drones, cameras which can identify strangers, sorting of the packages through warehouse bots, atop powered-up bread-sized boards. And since it is all on-device, robots don't have to be constantly connected to the cloud. They are smarter, faster, and safer. Chapter 5. Why developers are obsessed. Jetson is more than a little piece of hardware. It is a complete development environment optimized to work fast. And coders are fanatical about being able to get to prototype fast. NVIDIA did not leave Jetson only with the board. They developed an entire development platform: Jetpack SDK, DeepStream SDK Video Analytics, Isaac SDK Robotics, all are plug-and-play to AI developers. Just write Python, deploy TensorFlow models, even do real-time video inference, then deploy it in a few minutes. The ecosystem is already filled with pre-trained models, optimized libraries, and edge-ready AI paths. Looking to recognize faces, object detection, pose estimation? It has already been done. You only need to just install and go. So that is why programmers adore it. Since they are not forced to waste weeks in establishing frameworks, they can develop it within hours. The NVIDIA forum has hobbyists, engineers, and students all sharing techniques and updates in everything as astounding as smart elevators to underwater drones. What about amateurs? NVIDIA actually offers complete Jetson kits with cameras, modules, and step-by-step instructions. It is the Raspberry Pi of AI on steroids. Chapter 6. Tiny, cheap, and a hidden education. Jetson did not only arrive in labs, it exploded in classrooms. It is being used in universities, STEM schools, and even high school clubs to teach actual AI skills to actual careers. Jetson Nano being priced at only $99, the educational version has become the common platform to teach deep learning, computer vision, and robotics. NVIDIA has introduced Jetson AI Certification Program, a free, self-paced course where students study practical AI and pass an exam to acquire a certificate. Many students have done it before. Of the latter, schools are developing weather monitoring bots, smart traffic lights, wildlife detection systems using Edge AI. That is not a matter of theory anymore. Jetson puts it practical. It is applied even in developing countries, where GPU and cloud access are not that widespread. Jetson allows students to find out in real AI on real hardware, and do it without bankrupting the budgets. Tomorrow's artificial intelligence engineers? It is not the case that they are beginning in Silicon Valley. They start out in classrooms with Jetson boards. Chapter 7, how it stacks up to the competition. What do we have with Raspberry Pi? Intel NCS? Google Coral? Jetson not only holds its own, oftentimes it smokes others. Here's why. Raspberry Pi is great at general computing, but not meant to run AI inference at speed. It does not have support for CUDA, GPU acceleration, and deep learning frameworks. Google Coral is also very quick, but only supports TensorFlow Lite. The neural compute stick produced by Intel is developed to be plug-and-play, yet only effectively used in particular cases. Jetson? It allows the use of a complete TensorFlow, PyTorch, OpenCV, YOLOv 8, and so on. It can run in real time in full size and cost with GPU and TensorRT acceleration, which the other boards cannot. In addition to that, Jetson scales. Answer: start with Nano, then upgrade to Xavier NX or Orin when your product has matured. It is a single platform, prototype to production. This is the reason why Jetson boards are in production grade at NASA, Walmart, or Bosch. It is not toys, it is a cornerstone. Chapter 8, the future of Jetson and what's coming next. That is not all NVIDIA is doing. When Jetson Orin Nano and the Orin NX are already in the wild, the problem of affordable, small AI is about to begin, and it is quite on the verge of getting crazier. In 2023, the Jetson Orin Nano introduced a transformation of up to 40 TOPS of AI performance. That is twice the Xavier NX, and yet in a compact form. Orin runs several 4K camera feeds, transformer models, real-time NLP, and autonomous driving features all on device. It is also capable of edge servers, but still glorifies on USB-C cable. Over the next few years, NVIDIA will further extend Jetson across additional verticals: smart cities, AIoT, healthcare, and automobiles. Jetson may no longer be used purely to drive robots, as GPT instances running on Jetson in real time. Drone swarms or even home AI assistants may be practical applications of DeepStream 6 and CUDA 12 with LLM support delivered at the edge. But the best of it is, you do not need to have a $10,000 budget to start up. All you have is a Jetson and a good idea. And now you know NVIDIA didn't just build a tiny computer, they built a platform that's quietly powering the future of AI, robotics, and edge computing for the price of a used smartphone. So the next time someone tells you AI is only for the rich or the big, companies show them a Jetson. Because the next revolution is already in your hands.